Here is 4-3, which is the addition rule. Basically, in this one, we'll be doing the probability of A or B. The way that we look at this is that either event A occurs or event B occurs, or they both can occur. Okay, and this comes from a single outcome of the procedure. Keep in mind, the OR is thought of as the inclusive OR, which means one or the other, or both. So a compound event, right? An event combining two or more simple events. So that's basically what we'll be looking at. General rule for a compound event, this is just kind of the general intuition for how this is calculated out. We'll show you here on the next couple of slides. But when finding the probability that event A occurs or event B occurs, find the total number of ways A can occur and the number of ways B can occur. But find that total in such a way that no outcome is counted more than once. In other words, don't double count the overlap that occurs between A and B. So in this case, when I talk about don't double count when A or B occur, okay? So in this case, positive result is this row right here. The lied total is going to be the 42 and the 9. That's this column here. If you were to add these together, like A, the full total of A, which is 57, if you go down here and sum it, and this is 51, if you add those two together, you'd actually be double counting that 42. And that's what that basically that intuition means, is don't double count something. So in other words, okay, so intuitively what you can see is the probability of a positive test result or lied. Positive test result, these two, or lied. Well, you've already counted that one, and this is the next one you have to count. So you'd add those three boxes together, those three values, and then that would be the total number of ways that could occur, and then we got to divide by the total sample size, which would be the whole 4 digits added together. So again, you should get 66 divided by 98. So the formal rule, though, is the probability of A plus the probability of B minus the probability of A and B. So if we go back here, the probability of A is this total, and then divide by the 98. And then the probability of B is this total, and divided by 98. And then the and piece that they're referring to, that minus probability of A and B would be this piece right here. And so you'd be removing the 42 because you double counted it by accident. So intuitively, it's kind of what we said already. Feel free to pause and reread the slide if you want. Disjoint or mutually exclusive. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. This is an example of where there is overlap, so therefore this is not disjoint. These do not overlap, and therefore they are disjoint events. So consider the procedure of the randomly selected one of 98 subjects in the table, 4-1, determine whether the following events are disjoint. In other words, can they occur at the same time? Is there overlap? Getting a subject with a negative test result and getting a subject who did not lie. Well, it does not look like they are disjoint because you could have somebody who has a negative test result and did not lie. So there, true negative. Assume that one subject is randomly selected from the 98 that were tested to find the probability of selecting a subject who had a negative test result or did not lie. So negative would be this probability here. If we sum these together, 41 out of 98. And then or did not lie is this total right here. So we add these two together, but we would have double counted 32. So hence that's why you'd subtract it off. So in other words, you could have 15 plus 32 plus 9, and that'll give you the total in that numerator, and then you divide that by 98. Yep, so just like I said, you can see that there. Now, complementary events are important because they are disjoint and must be disjoint. So it's the probability of A and the probability of not A. In other words, you have maybe it's sunny out, and the probability is not sunny out. You add those two together, you get 1, which is going to be really cool because that's the rule of complementary events. But basically, it is impossible for an event and its complement to occur at the same time. If they do occur at the same time, then they are not complements. So here's the rule of complementary events. If you add the probability of A plus the probability of A complement, that should equal 1. Because remember, probabilities lie between 0 and 1. So if this is a probability and this is a probability, you sum them together, this is the full sample space, and that's why it equals 1. And I'll show you that here on the Venn diagram on the next slide. Again, you can rearrange this with some algebra, right? Subtract this over to the other side, and get 1 minus probability A. You could also subtract this to the other side, and that's how you can figure out the complements. And that's why it's really helpful and useful. You'll see that we'll use this when we want to do the probability of at least 1. We'll find that that is equal to 1 minus the probability of none. So Venn diagram for the complement of event A. So total area is 1. And so this is the probability of A, and then everything that's not in that yellow or in that pink is considered a complement. If you added these two together, it should sum to 1. So that's also how we can get a complement. We can do 1 minus the probability of A, and that'll give us a complement. And that's all of 4.3. Feel free to ask me questions if you need to.